Today we are going to do slip ring induction motor load test. So you can see that the 3-phase slip ring induction motor is connected with the load using a brake drum, and the specification is, that is nameplate is power equal to 3 HP, voltage is 415 volt, current is 4.7 amps and the speed is 1440 rpm, and the circuit diagram is given. As per the circuit diagram we should connect the connections, and you can see spring balance is connected to the motor by the brake drum connected in the motor, and this is the rotor resistance starter mainly used to start the slip ring induction motor. So the connections as per the circuit diagram is very easy. You can see the main connection. The main connection should be given from the main of the motor to the mains, and the rotor connection to the rotor and stator connection to the stator. And you can see a start button, green button. By holding the start button continuously and by rotating this rotor switch 1, 2, 3 till run, we should hold the start button, and when the motor starts running only we should release our hand from the start button. And there is also a stop button in red color. Now you can see the panel here, that is TPST switch is here, and the panel, and also the apparatus we are going to use, that is 2 wattmeter of 500 volt and 1 voltmeter of 500 volt and ammeter of 10 amps, and also a tachometer to calculate the speed or measure the speed of the motor. You can see all the equipments, that is apparatus, are here, and also the required connecting wires are placed here. Now going to the connections, as per the circuit diagram we are giving the output of the motor to the meters as per the circuit diagram to the main of the rotor resistance starter. You can see it is given to the main of the rotor resistance starter. And to the board from the rotor resistance starter we are giving to rotor connections and stator connections also finished according to the circuit diagram. So total connections are finished. Now we are going to power on the motor using that MCB. So we are going to switch on the MCB, and we are now going to close the TPST, that is triple pole single throw switch, and by using the rotor resistance starter now we are going to start the motor, and when we start the motor it runs in the rated speed. See, we are going to starting the motor, and the motor runs in the rated speed, and the first, see, you can see the motor runs in the rated speed, and the first reading is no load reading. We are going to write down the readings of load voltage, load current, first wattmeter reading, second wattmeter reading, and S1 S2 reading, and also the speed. After this, according to the load test, we are going to apply the load by the spring balance to the brake drum, and we are going to take the readings for 2.5 amps, 3 amps, 3.5 amps, 4.5 amps and 4 amps till you can take reading till 4.7 amps maximum, but we are doing only for 4.5 amps. And after finishing all the readings, we are now going to calculate by using the formula the output power, the input power, the percentage slip, percentage efficiency and cost theta as PF value by using these readings. Now next you can see all the readings are tabulated in a paper and calculated. So after giving all the connections as per the circuit diagram, we should run the motor and take the following readings. That is, you can see load current, load voltage, spring balance S1 S2 and difference of spring balance reading S1 and S2, and wattmeter 1, that is observed reading and actual reading, and wattmeter 2 observed reading and actual reading, and the speed by using the tachometer, that is the speed is calculated using the tachometer, that is in RPM, and torque Nm, and input power and output power, percentage efficiency and also slip and cost theta value, percentage slip and cost theta value. Now by switching on the motor, we are taking the first reading, that is no load reading. You can in low load reading we can take IL load current, VL load voltage, S1 and S2 and S1 difference S2, and wattmeter reading 1 and wattmeter reading 2, and speed of the motor. And now you are going to apply loads using the spring balance, and we are going to take for different load. Now we are going to tight the spring balance, and for different loads we have taken, you can see the for different loads, that is for 2.5 amps and 3 amps, 3.5 amps and 4 amps and 4 till 4.5 amps, because the synchronous motor we can operate only till 4.7 amps. So by applying the load, various load, applying various load using the spring balance, this spring balance, we are applying various loads using spring balance, and we are taking the load current, load voltage readings. You can see here this and wattmeter reading and wattmeter 2 reading, and also the speed of the motor is measured using the tachometer. Now by using these formulas, that is to find torque S1 difference S2 into R into 9.81 Nm. So you can see the spring balance reading and radius of the brake drum, and next output power equal to 2 pi nt by 60 watt, N equal to rotor speed, T equal to torque in Nm, input power W1 plus W2 watt, that is wattmeter reading, and percentage efficiency equal to output power divided by input power into 100, and slip equal to ns, synchronous speed minus and speed divided by synchronous speed into 100. So ns equal to synchronous speed and n equal to speed of the motor in rpm, and power factor equal to W1 plus W2 divided by root of 3 into VL into IL. Now by using those formula, we are going to calculate the make calculation for the second reading. So 2 pi r equal to 0.64500 m. So r equal to 0.1027 meters. Input power equal to P equal to W1 plus W2. So W1 equal to 760 watts and W1 plus W2 equal to 760 plus 100. So using this formula, you can see W2 equal to 100 watts, that is equal to 860 watts is the answer. And torque equal to S1 difference S2 into R into 9.81 Nm. So S1 difference S2 equals to 4.2, that is for second reading, and radius equal to 0.1027 into 9.81. So torque equal to 4.2314. Next, output power equal to 2 pi nt by 60, n equal to 1456 rpm. So T equal to 4.2314 the torque. So output power equal to 2 into pi equal to pi value is 3.14 into n equal to 1456 into 4.32 divided by 60. You can get output power equal to 644.84 watts. Next, going to percentage efficiency, that is percentage efficiency equal to output power divided by input power into 100. So 644.84 by 860 into 100, you get a percentage efficiency for the first reading equal to 74.98, and cos theta equal to W1 plus or minus W2 divided by root 3 into VL into VIL, that is equal to 860 divided by root 3 into 2.8 into 372. So cos theta equal to 0.5314 pf, and percentage slip equal to ns minus n divided by ns into 100. So 1500 minus 1480 divided by 1500 into 100, that is percentage slip equal to 1.33%. So by using the formulas, we have found out all the torque, input power, output power, percentage efficiency, percentage slip, and cos theta value, that is PF value. You can see by using those formulas, we have finished the tabular column. And this is the model graph of the load test on slip ring induction motor, that is mechanical characteristics and also electrical characteristics. In mechanical characteristics, the torque versus speed is drawn. In electrical characteristics, we can see output power, output equivalent power versus cos theta, and speed versus output power, slip versus output power, speed versus output power, load current versus output power, and torque versus output power, and percentage of efficiency versus output power is drawn. You can see clearly. Now using the formula we have calculated and filled the tabular column of load test and slip ring induction motor. By using this we have drawn the graph by using model graph. You can see